from my background in engineering and now in geography, I tend to become interested in projects that have elements of both. I think a lot of our societal problems, go outside disciplines, and so I'm always trying to do that in geography. So I'm going to talk about 3 projects, but just briefly on my path. So I went to Rice University, and I came out and I got a job working for the US EPA. And so as part of the Superfund program, I did this, right? We're drilling wells and taking soil samples. We write reports and say how bad the site is for human health and the environment, essentially. But along the way, I saw some shocking things about people having waste in their yards and not knowing the impacts, and they're having, oh, by the way, they've had some birth defects of their kids. And so I could see that there's sort of this human element to things that we didn't really study as much as part of the EPA assessments. I got my master's degree and ended up starting working on floodplain mapping. After that, I did another stint in consulting, building flood models for FEMA. So then Katrina hit, and I was seeing all these images. I'd been studying floods and modeling floods for 8 years, and I realized that there's this big dimension to this human dimension to the thing, to floods, and that's why we really care. And so I went to geography to get a PhD because I could start studying the human elements of problems. And so I went to South Carolina and focused on modeling social vulnerability, and then so got a job in academia and finding ways to merge all of these in different studies. And so I'm going to talk about a few. So here's sort of an outline. I'm going to talk about 3 studies that are in their end stage. One about sort of this mix between water quality and flooding, another about modeling social vulnerability, and a third about just interdisciplinarity. And this is kind of the workshop that Dean and I have been part of. So this is, I guess, one sub-area of my work, sort of flood risk. What are the associated impacts with, extreme events of different magnitudes? So these are some of the questions that I might look at in different studies, but mainly I'm going to talk about kind of this dimension in this current study. So I'm from Iowa now, and we have a serious problem with nutrient pollution. Iowa is dominated by agriculture, like massive industrialized agriculture. And we put a lot of inputs, fertilizer inputs, onto the fields, and they go off into the water, and it's causing big problems all through the Mississippi Basin. Iowa's a big contributor along with Illinois. And so around 2008, there's worry from a lot of these states of impending sort of federal regulation of this. I mean, now it kind of seems kind of silly that's going to happen, but there's huge exemptions in the Clean Water Act around nutrient pollution. So these states came together, this hypoxia task force, and the state of Iowa decided to go with a voluntary strategy called the nutrient reduction strategy. So they're trying to reduce nutrient, nitrogen and phosphorus concentrations in water. So there's a lot of projects going on around that, but if they put in new practices on the landscape, can there also be other benefits in terms of flood risk reduction? And so this is a project that we started investigating with the Nature Conservancy. So really the question is, if we're putting changes in agricultural practices, I'm listing a bunch, but here are some of the major ones, including like no-till agriculture. So we're leaving organic matter in soil in place, cover crops, kind of a similar thing, growing oats, for example, during the winter, and constructed wetlands. So some of these really for reducing nutrient pollution, but can they actually offer benefits also in terms of reducing flood loss? I don't know, sounds plausible proposition, so we started looking at it. So this, like these other studies, everything I kind of do now is sort of collaborative. This one is more on the engineering side, and so working with some hydrologists from Nature Conservancy, another one from Minnesota, a hydraulic engineer from Iowa, and so they put together these scenarios of different management of the landscape you know, a baseline and then some alternative scenarios that we're going to model and see if they, how they affect flood losses, essentially. We sought to take advantage of some ongoing work. Iowa had massive floods in 2008, and there's an influx of funds to update flood maps. And so there is a statewide floodplain mapping initiative that resulted in, for most of the state, lots of geospatial outputs of flood depth. So this is the depth grid for the 100-year of flow. This is for the 500-year, the 25. All of these across the state at really high resolution. Can we use these existing data sets in conjunction with our analysis? And so this is one of our goals. Essentially, we're connecting models, okay? SWOT is a big agricultural model where you can put these scenarios, these agricultural scenarios, into the model and see what the effect is on stream flow, okay? Typically then you would take these stream flow estimates and put into a hydraulic model where you're going to estimate the floodplain, you know, depth, breadth of the floodplain, for example. And so we're using SWOT here. We're going to bypass the floodplain analysis, though, because we have these data from the statewide floodplain mapping initiative. And then we can model impacts, economic impacts, using another model called HAZIS. That it's geospatial. It can, you know, you define your flood and then all the way up to estimating losses. So the idea is essentially connecting these models to translate all the way from changes in agricultural practices to what their economic benefits are in flood loss reduction. So we're bypassing the floodplain analysis. We're trying to stick these flood depth grids right in the middle of it. And this is an opportunity, but provided a lot of challenges as well. So we broke the approach into several different pieces. Yes, we needed to do this hydrologic analysis. So this guy from Minnesota, he is modeling SWOT to try and get this daily discharge information. Ultimately, we want to try and get an understanding of the relationship between discharge in the river and the frequency of extreme events. Okay? With me and my graduate student, Federico, we want to take these depth grids and estimate losses and get a relationship between economic loss and discharge. Then you can combine these two. There's discharge on both of these axes. You can get this relationship between frequency and loss. So for the 100-year event, it's X million dollars. For 500-year, it's Y million dollars, this kind of thing, this relationship. Okay? And then how does this change for different scenarios? That's kind of the goal. Okay? By combining all these models, combining all these people. Fairly early on, though, we ran into some problems. SWOT produces discharge in terms of daily mean flows, average, you know, by day, but if we want to understand like 100-year events, we need annual peak information. And it's sort of like, this is us, you know, a few months into the project where we have the SWOT folks and then the modeling folks, how to connect these two. And it almost sunk the project, actually. And I think it was really useful in this case to have people from different institutions that had a similar level of disciplinary understanding, even though our institutional demands were very different. We could speak sort of the same language to get through this. We ended up finding some existing relationships where we can translate the daily flow to the peak flow to get through this. And then we're able to proceed. So I'm bringing this up because later I'm going to talk about sort of some challenges with interdisciplinarity. And I think this is emblematic of one of them that we had to get through. But it slowed us down quite a bit. In the end, we're able to produce estimates of economic loss. Okay, so this chart is showing the different scenarios here on the y-axis. Here we're seeing losses. So these are really in millions, since they're so 2 million, 5 million, 8 million. And then the baseline scenario is in blue, and then reductions in flood losses shown here. So what we're finding is, yes, there is these changes in agricultural practices that are implemented to improve water quality can also have some benefits in flood loss reduction. Now, what if, there's some choices in which practices are applied to the landscape. So maybe we can have a different set of decision points if now we're trying to optimize on both flood loss reduction and nutrient reduction versus just one. If we can have more optimal use of resources. We did find that these best management practices are more effective for the low frequency event, for like 2-year, 5-year, 10-year storms. And it kind of makes sense because they're not these big structural things. But it's hard to make decisions just based on results for individual return periods. We want to have an aggregate measure, so we're going to compute average annualized loss or average, annual expected loss. Okay, we're going to aggregate the results from all these different return periods. I'm showing 4 here, but we actually had 8. So a lot more data. So we computed annualized loss, so we can actually compare BMP performance. And so this table is showing how they perform comparatively in an absolute sense. And so, and then here on this half, in a relative sense. Okay? And we also try to understand the robustness of these findings to different assumptions. Like, what if the price of corn is really high, or the yields are really low for soy in 1 year? How do these loss reductions change? Essentially, what we're finding is that pretty much all of these practices have loss reductions. They're fairly modest, but some of them reduce impacts a lot more than others, like these cover crop scenarios and building wetlands, for example. But this is all on the benefit side. It's not looking at the costs, and so that's a whole nother, element. So wetlands looks like it's providing by far the most relative impacts in terms of loss reduction, but farmers may not want to do that because they're going to be forced to retire parts of their land permanently to build these wetlands, and then there's these construction costs that are a lot more. Implementing these is a lot more than, say, cover crops. So it's a different way to look at the differences between these different approaches for addressing this real problem about impaired water quality. So I wanted to put this up sort of an example of like, I was just talking with Dean. I was like, what is actually synthesis? What is data synthesis or data-driven synthesis? Is that what I said? What does this apply to models maybe? And so I do a lot of thinking about this with talking with different disciplines. They're using different data and models. So that's one study. It's more of sort of harkening back to my engineering days. But my core interest is with this idea of social vulnerability to floods. Why in Katrina are so many people that died poor, black, and elderly? Why does it happen that those that are at the bottom levels of our socially stratified society tend to be impacted the most? Shouldn't we have a better understanding of that? Shouldn't we be able to plan better around that? So this is sort of the idea of social vulnerability models. They purport to say, look, we understand that human susceptibility to disasters, a lot of the determinants of this are demographic characteristics, or the processes that we can represent with demographic characteristics, let me put it that way. So, it's kind of common now. We can build a social vulnerability index. We can get data. We know that the poverty has some effects, and if your land tenure matters, and age and gender all have influences on whether you're more or less susceptible to negative impacts. So the way that the field has kind of progressed is that, like in the 90s, all these people are doing these qualitative studies, surveys, going after like Hurricane Andrew or Loma Prieta in the 80s, late 80s, yeah. And we'd understand some of these, how vulnerability is progressing. And then sort of in the late 90s, we were like, oh, we can get demographic data and we can build models. And so we grab these variables and then we put them in together, we add them together, and therefore we've modeled social vulnerability. Declare victory, all right? Let's now go put this into effect. And it's alluring, this idea of taking this big construct of vulnerability or resilience or sustainability and reducing it to something that can be used to manage and make decisions and allocate resources. Reduce complexity, you know, reflect multidimensionality. But these indices are actually models. It's not enough to just take data and put them together and therefore you've modeled something correctly. But that, I don't quite understand, but this is how things have progressed. And now you're seeing these indices being used by counties and states all over the place. You know, how are we going to allocate resources for disaster recovery? Oh, well, let's take a look at the social vulnerability index. And, you know, these are the places that might need it more. So that, I think that's dangerous, because how sure are we that the places that we say are the most vulnerable in our models are actually the most vulnerable? If we start allocating resources to places that indeed are not, then what happens to the places that are truly in need that aren't getting resources? So I think we can have, I don't think the answer is not use indicators because people want numbers. For me, the answer is to make better indicators, okay, that are more informed with what's going on. So lots of research questions around social vulnerability. These are some of the more typical ones. But what I've been interested in the last 5 or 6 years is like, how valid are these measures? How valid are they internally, statistically, and then externally, how well do they comport with actual disaster impacts? And although these indicators are starting to be used, and now everybody, you know, resilience indicators is all the big thing now, I don't think really anybody knows how well they perform, which I don't understand. So this study, we're looking at this question. Primarily, the way that we consider validation for these models is by acceptance. Well, there's 20 studies on this model, so therefore it must be valid, and so then we're going to use it. Okay, so this is the most prominent model. This is a social vulnerability index that came out of where I went to school, University of South Carolina, and these papers are Soviet in Brazil, Soviet in Portugal, Soviet in Norway, you know, and all over the US. People are using it at different scales, different time periods, to build maps that show areas of higher social vulnerability and lower. A newer model is coming out of the Centers for Disease Control. So you have a bit of a different formulation, different statistical approach, different input indicators, different ways they're putting them together. They're going around saying, oh yes, we can use this for adaptation to climate change and for health. And so there's a city called the city of Dubuque. It's in Iowa. It's along the Mississippi River. Not a really big city. We're having a project with them, and we're talking with them, and the sustainability director came in and said, oh yeah, we had this workshop with the CDC and social vulnerability. We're going to use it now. And so it's percolating down to even, you know, smaller areas. If people are, this is their first foray into social vulnerability, and if the CDC's behind it, then it must be ready for prime time, right? So validity of models by acceptance, that can be dangerous. Another way that people tend to look at this is by convergence. I'm going to come up with a new model for social vulnerability, and to tell you if it's valid or not, I'm going to compare this to this other model, which is generally an accepted model, all right? So if I build my model and it's similar to the CDC model, then I declare my model valid, and we can then use this. And so we, in our study, we looked at this, right? Do alternative models agree? And we found, just based on sort of correlation and visual inspection, this is kind of the way people do this, yes, they generally agree. Positive directions, fairly high correlations, different formulations of the model. One, the social vulnerability index, a hierarchical model where indicators combine into themes and then into the index. This is the CDC model, and another model that's based on not identifying areas of high, medium, low, medium, and high vulnerability, but what are the dominant forms of vulnerability in different places. It's a different way of looking at it. They fairly agree. Another approach is looking at robustness. So statistically, are these models reliable? So if you make changes in the inputs, your parameters, your approaches, how sensitive are the outputs to these changes? And so a really robust model, you can tinker here, and it's not going to change much there. And so there's all these decisions. It's not, I use the word model a lot instead of index because you got to make all these choices. And when you make these different choices, you can see, well, if you formulate it in this structure, then how you transform your variables. Is it the number of elderly or the percentage of elderly or the number of elderly per square mile, just for this one variable, can make a big difference. Another model configuration is how you weight them. Another one, the SOVI, it's all of these. It's a mix. It's hard to pull apart. So these choices really matter. People aren't really thinking about that either. But for our study, we're thinking about this idea of construct validity. Do your theorized understandings of how social vulnerability manifests, do they align with what actually happens when you have a disaster? So really, if you're thinking about on the theoretical plane, then you should be able to answer before you study, if you are vulnerable, then what? So if through social, institutional, political, economic factors, some population groups are more susceptible to adverse hazard impacts, then what? What do you think might happen? I'm asking y'all.
Higher mortality rate.
More people die if they're more vulnerable. Okay. Yeah.
Higher percentage of like asset loss.
A percentage of asset loss. Okay. So already sort of, here's an absolute impact and here's a relative impact. It's good. Yes?
Slower recovery?
Slower recovery. Maybe residents don't come back as fast or they don't get back to where they were. All of these are plausible. Any ideas on like which are stronger connections, which are valid, at which scales, for which disaster types? We don't know this. Generally, it's like we've reduced vulnerability to a formula that's just universally applied. So yeah, maybe you're more likely to die. This is looking at a medical social vulnerability index and looking at relationships between mortality and social vulnerability. So the places that it lines is the darkest one. It's not a whole lot of counties where those align. Maybe you need more government assistance after the disaster. And this is the variable that we're looking at. This is Hurricane Katrina. Maybe you're more likely to be displaced. We're talking about displacement a little bit earlier, not so much with these extreme events. Maybe you're more likely to live in low-lying areas, or at least for flood, because the property values are lower, or historical discrimination, or both. Maybe you're likely to have more acute or chronic adverse health impacts. All of these are plausible. None of these are really fully looked at in terms of the theorized connections with social vulnerability. So you look at all the studies, there's lots of them. I wrote a proposal to NSF, and I asked the program manager, this was like 5 years ago, here's my idea, and he's like, well, you know, social vulnerability modeling is sort of becoming like a cottage industry. So be real specific about your methods. And so that was useful. Wrote the proposal, was fortunate it got funded, and so we started looking at sort of how models are built. With construct validation, right? Is your construct empirically manifested? Not many studies. Big variations in the scale of analysis from census block groups to tracts to zip codes to counties. Lots of different ways these indices are designed, the configuration of them. Changes in the dependent variables. We just heard a bunch of plausible ones here. Some are doing correlation, some are doing regression, but very few of the ones that are doing regression are actually accounting for spatial autocorrelation, which in geography we know that can actually invalidate a lot of the assumptions with ordinary least squares regression. And also, what about the hazard? If you say a place is vulnerable and then more people die, does this mean because they're more socially vulnerable, or maybe just the disaster was worse there? There's higher wind speeds there, or there's more flood depth. So we need to be able to separate these. So very few studies and lots of diversity across this, meaning it's hard to understand in any sort of generalizable sense how to understand this idea of construct validity. So we looked at Sandy, We looked at this idea of government assistance from the individual assistance program. People are applying for housing assistance, for, renters that are uninsured that have personal property losses. That might be a vulnerable group. We know renters are a vulnerable group. Percent housing damage, right? All these are relative indicators. Percent property loss. So Sandy, we looked across the affected areas in Sandy in New Jersey and New York, essentially. So I'm generally not a fan of like putting up statistical tables during presentations, but I'm just going to run you through some highlights. We looked at the index level so we can compare indices. We looked at 4 different model formulations across 4 different outcomes. There's a lot of sort of statistical analyses. 3 of these indices are shown here, SOVI, the CDC model. Big variations across the indices in terms of what they're able to explain. So the SOVI model did a pretty good job of explaining the applicants for housing assistance, pretty good job of explaining the percent damage in homes. The hierarchical model did better, was able to explain more outcomes. Remember, SOVI and SVI are the dominant models. The CDC model was troubling, though. It's actually the outcomes it's significant for are in the wrong direction. So the places it's saying should be most vulnerable, or actually it's the opposite that's coming up in the outcome measures. So as CDC is going around saying we should use this model, this is worrying to me if people are going to start making decisions on this. But this is just one case study, right, and just a few outcome variables. What we found is that spatial dependence was massive. All of our models in ordinary least squares regression we had to throw out and use spatial regression models.
This is just for Sandy?
It is. It's just for Sandy. I think we ended up having, so this is our sample size. It varied depending on the outcome measure, at the census tract scale, okay? And we also controlled for flood depth, which you can see, I put in here? Yeah, it's significant for many of the studies. So trying to really pinpoint the relationship between social vulnerability and these outcomes. But then these indices, a lot of people criticize indices because like you can't reduce this to one number. What's actually going on here? Is it that it's poverty that's governing the vulnerability? Is it race? Is it functional needs? Is it something else? And so we looked at the pillar level. All of these models are sort of constructed at aggregations of sub-indices up to the index level. So I'm just going to show you one here. What's driving these index level results for SOVI? This is the most prominent model. Well, poverty and access and renters are coming up in the negative direction. It seems again that this applicants from the outcome variable maybe is most aligned with this idea of social vulnerability, right? All these studies have looked at all these different outcome measures. Well, theoretically, what should we be focusing on? And so lots of differences in at the sub-index level in its ability to predict or to explain these outcomes.
And that was Sandy?
Yeah, this is all one study. Same study area, but instead of the whole index, we're looking at the pieces of the individual pieces of the index. So this is aggregated, so this is one number, SOVI, and these are all the components, these 8 components of SOVI.
I'm wondering with the no auto renters in that area, 'cause I think you could speculate that they're worse off, like well-being, but then in the New York area, a lot of people don't have cars and are renters.
Yeah.
Or the yuppies, like, it seems like it would bifurcate.
You're right, and this points to the need that you can't apply these universal understandings of who's vulnerable, right? If you don't have a car and you're living in Manhattan, that doesn't mean you're vulnerable, right?
Yeah.
But this is the kind of thing that people do. And so, yeah, in our models, we're finding one cluster of, this is Manhattan. And so, yeah, it makes sense that it's not coming up. But then shouldn't you adjust your model for that? And maybe not potentially put this variable into a place where it doesn't apply? How does this affect which kind of outcome variables you consider to comport with social vulnerability? there's sort of an absence of thought that goes into a lot of this modeling process. So it's just, I'm dissatisfied with it, and I'm actually baffled by it. I was watching a presentation the other day where someone gave this graphic of like lemmings going off the cliff, which apparently is like not actually real. I mean, but I think that's what's happening. You know, there's like one study and it gets a lot of citations, another study, and then you start tracing back like why people made certain choices. And so this study says, why did it? Because of this study, and this study is because of this study. And it all goes back to like these 3 studies that you read them and like, why did you do this? And they're like, well, we just did this. And then that becomes a standard, and that just becomes accepted way of doing things. So what we found, well, what's the big takeaway here? We're still working on this. This paper is probably going to go out in another couple of weeks. We're having a meeting today to like hone our core message. But how you build the model matters a lot. Just because you say it's social vulnerability, well, how did you construct this model? What are your assumptions? What are your parameters? The leading models had the lowest explanatory power, which is troubling. We can go down to the sub-index level, and we can understand give a better understanding of what's going on. So we recommend that future empirical validation studies look at multiple levels of these models. Certainly need to take into account or to test for spatial dependence. We had to throw out every single regression model because of violations in the ordinary least squares regression, and control for hazard, and really think carefully about the scope of the analysis. So essentially, where is a disaster? Sandy hits, how do you bound the disaster geographically? We had a long discussion about this.
So I worked on the science team that looked at Hurricane Superstorm Sandy and the federal response and how they were supposed to do the investments afterwards. And it was really more sort of a war planning type of analysis and using those indicators. And the geography that we were focused on was based upon precipitation and the insurance claims for that. So it was inclusive of New Jersey, Connecticut, New York. Maryland was not included, even though it hit it.
Yeah, so that's certainly one way of bounding the disaster.
Right.
Where these outcome measures happen, and where's something about the hazard. Right.
When you have to bound it geographically, you also have, in our case, we had to bound it in terms of the future.
Yeah.
And we had to look at what happens if our hurricane hits again in 3 years of the same size with no response.
Well, you pointed to a couple options, right? We can say, look, ours is flood depth. We're going to say the disaster is wherever the flood exists. Or we could say the disaster is wherever we have a non-zero outcome, which differs across measures. You can actually have outcomes where flooding didn't exist. Right? So maybe there's indirect effects. Or maybe you do it based on where money's flowing. You know, particular counties or communities are getting post-disaster aid, and so there's this management aspect to it, right? Indicators need to be usable, and so maybe we should do it based on administrative units, but this really matters. Like, you really need to conceptualize what the disaster, and because that can affect the statistical results as well. And so I think overall just more thought needs to go into it on this theoretical level, but also we need a lot more studies to try and understand this. And so we're trying to push the field forward and saying, stop doing all these indices there's a million studies, and all they do is like, well, we looked here and we use this model, and here's social vulnerability, and here's a map, and here it's high and here it's low. And the next study, well, we did it over here, right? And then we did it over here. This is like half the field. I don't get it.
If I may just for a second,
yeah.
It's not accounting for how did the disaster preparedness and response occur. And Margaret gave an example to human health and mortality.
Yeah.
And then Louis gave an example to property, and the order was to shelter in some different pieces.
Good point. So you talked about preparedness. I view it as sort of a temporal understanding. Are you looking at vulnerability well in advance of the storm, like a year or 5 years as you're planning? Are you looking at it as the storm is approaching, immediately afterwards where there's been impacts, or in recovery to the disaster? And there may be different levels of vulnerability within the same group, depending on what phase you're looking at. There may be some groups that aren't vulnerable at all in one stage of the disaster and very vulnerable in another. And so that's another element that we need to think about, right? There's a lot more complex than most of the analysis is portraying.
It seems like there's been a movement, and Nancy Grimm's an example of defining disturbance as a function of both the biophysical aspect, so here it might be level of the flood at a certain place, and the response.
Yeah.
So you may have that flood but low response because they had certain measures in place. It doesn't mean, and that's the clue to perhaps what could be done.
Right. And that may change. That very well may change if you're looking at one community and then another place. And so our model should be flexible, or they should consider these place-specific processes. So that's also a collaborative study where instead of working across engineering, are we all geographers? We are all geographers on this one. But one of the guys is in France. And so we're constantly navigating sort of cultural understandings and language differences, the way we express ourselves. And so there's a big communication aspect as well to this. Which leads me to this last point about interdisciplinary teams. And I was talking with some folks earlier, and one of my conclusions about working in academia is that my #1 resource is my time. And finding ways to optimize the use of time. I'm interested in collaborative research, which tends to require more time, which can be very costly if I go off in a direction that doesn't bear fruit. So I've been thinking a lot about, maybe I could think about some things more on the front end so I can make decisions about which interdisciplinary collaborations to invest in that are likely to be successful and which may not be. And so Dean and I are part of this workshop where we're doing these thought pieces, and we're asked to look at these different elements of interdisciplinary research. And so our paper is like, we should be thinking, it's not just about who's on the team, but the processes of collaboration that matter, and we should be thinking about this when we form our teams, perhaps, okay? So I think flood hazards research is perfect for interdisciplinary research. If we want to understand a disaster, we need to understand the physical dimensions. We need to understand, and so you may have natural scientists and engineers for physical processes, but also certainly we know that social dimensions can have a major influence on which disasters occur and then their effects afterwards. And so, these institutional, social, physical dimensions, we need to understand all of these to really understand disaster. This is ultimately what took me out of engineering, because I realized I couldn't understand this by sitting in this world. This is where I lived until I was 35. Decided to go back to school. So, however, there's this need. The process is interdisciplinary, but our research is largely not. It tends to happen in these silos, and so people focus on risk analysis of losses and insurance. Others focus on ecosystem services, and a lot of times, or statistical modeling of extremes, and don't always talk to one another, don't even recognize that there's these other aspects. And so, we started reading a lot of the team science literature and sort of the interdisciplinary literature. And I know there's all these definitions of interdisciplinarity and transdisciplinarity, and it kind of get tiresome at some point. But the aspect that I focus on is sort of this idea of knowledge integration as a success marker of interdisciplinary research. And so as we're forming our teams, can we be more intentional about its construction that's most likely to lead to knowledge integration. I think we can do a lot more. A lot of times it seems like a lot of the NSF calls is just like interdisciplinarity equals you have a researcher from this area plus a researcher from this area plus a researcher from this area. And I think it can do more. So one of the ideas I think was really interesting was this idea of collaborative proximity. So a lot of the economic geography literature has been doing this for 2 decades, where there's these different dimensions, primary dimensions, a spatial dimension, like how physically close are the members of the team, but it can also be temporal, like my researcher, my colleague from France, you know. We have to figure out, there's only certain time slots in the day that it works for both of us to be on a call. And so when you're, you know, it can be, the spatial proximity can help start collaborations. It could also help with more interaction if you're close, but it can stifle innovation if you're too close. It's cognitive alignment. So that was really useful in our project when we came to this, the BMP project for flooding and loss, where we came to this, well, we have SWOT that has these daily mean flows, but we need these annual, like, how can we solve this problem? Well, we had to talk with one another, and the ability to understand one another really helped us get through that. Social interaction, probably the least appreciated one, but I think it's critical. So we have this big project with housing and urban development looking at flood resilience. And I just remember a meeting we had a few months ago, and we had built this survey for the city of Dubuque. They're reconstructing homes in older, low-income areas. And they wanted, other members of the team wanted to be able to take that survey and apply to other places in Iowa. Okay, but then we see the result, and it's like they'd taken this 35-question survey that was broken up thematically, and it reduced it to like 8 questions, right? And like, this is how we're going to measure resilience here. And I was, you know, it was early. I didn't sleep much that night. I was just cranky. I was like, look, there's a construct here, and our measurement tool needs to be in alignment with this construct. You can't just break these linkages and say you're doing. And so I was kind of like getting snarly at people. But you know what? We had been working together for a long time. And if I'd have done this in another environment, people would have been like, maybe just like, the hell with him. What is wrong with this guy? He's not great to work with. But I knew these folks, and they're just like, look, he's a little grumpy that day, right? It wasn't a major blip. The message was received, and we moved on. But it's because we had invested all this time earlier in these social interactions. But you know, Iowa, the towns are far apart, and so we get in van rides a lot together. And it turns out that's been really crucial for us getting to know each other, but also bridging this cognitive gap, which was large in the beginning. We're starting to understand each other through social interactions. And finally, this institutional. There are certain rules that govern what is success, what are the barriers and opportunities. You know, we have one person who's a program evaluator. She's not faculty. So she has different levels of security in what, you know, how far she can go off path and what kinds of things she can. There's status differences perhaps in the team. If someone's pre-tenure versus post-tenure, they may have very different incentives. So all these matter, and maybe we should be thinking about this. So we want to get to knowledge integration. So maybe we can, in advance, think about these different dimensions. And so this is like a conceptual radar chart. This is our team in blue when we started. Ideally, I think you want to be in the middle, because at both ends of the spectrum of high proximity and low proximity, you can have problems that can stifle knowledge integration. So kind of want to go for this Goldilocks zone. We kind of got lucky. I think a lot of the social interactions helped bring us together. I think we're doing good stuff now. But what if we could identify this in advance, where we're thinking about team formation and the process of interdisciplinary research, where we can say, oh, you know, we have this really high spatial proximity. Well, we need to really be careful about it stifling innovation. But we have really low cognitive proximity. So we need to have more time getting to understand each other and how we approach the problem, differences in jargon and language. Conceptual modeling can be really useful for that. And so this is sort of our thought piece, and I think I want to try and apply this because I'm, as one of the, so I sort of sit between disciplines, and so I tend to get asked to be parts of lots of things. But I need to have a better way to maybe understand the potential of success. And so a lot of this is about disciplines, a lot of it is about the people, though. So can water quality improve? Can it provide co-benefits? Yes. Probably modest at this point, but maybe it can be a tiebreaker between investments in different agricultural BMPs. How valid are social vulnerability models? Well, unclear. Some of the dominant models, troubling in their ability to explain at least this one set of indicators around needing government assistance, unmet needs. We should focus on collaborative processes when forming interdisciplinary teams. So some ways to think about this. And so that's my presentation. This is my grad student who helped with some of the flood modeling part in Iowa and some of the collaborators associated with this project. So thank you for your time.